name's Kendra, and today we'll be learning about stoichiometry. There are 4 different types of stoichiometry problems: mole to mole, mole to mass, mass to mole, and mass to mass. For each different problem, you use a table. Let's go over them. For a mole to mole problem, you take what's given to you in the equation, the given moles of X, and you put it right here. Down here, you always make sure that the units match. So down here will be your moles of X, which you will find in your balanced equation. And then up top is your mole of Y. In every equation, you multiply across the top, multiply across the bottom, and then divide. And there's your answer. For mole to mass, you put your given moles of X here. Down lower, your moles of X from the balanced equation. Up top, moles of Y from the balanced equation. And then from the periodic table, you go down here is always 1 mole, because anything you get off the periodic table is always equal to 1 mole. And up here we have the grams of Y, which you would go to your periodic table and figure out. Up top with mass to mole, we have the given grams of X. Down lower, we have your grams of X, which you get from the periodic table. Up top, 1 mole, because anything off the periodic table is equal to 1 mole. Down here is your moles of X and your moles of Y, which you would get from your balance equation. Down here, mass to mass. Up top, you'll put your given grams of X from your equation. Your grams of X from the periodic table, 1 mole, because that's what it's equal to. Mole of X, mole of Y from your balanced equation, and again 1 mole, and then your grams of Y from your periodic table. We are going to be using this balanced equation to do an example of each different kind of problem, starting with a mole to mole problem. Given 2.6 moles of H2, let's try to find how many moles of H2O are formed. So we make our table. Up top, we will put our given moles of X, which will be 2.6 moles of H2. Down here, we will go to our balanced equation and we look at the coefficient. And the coefficient tells you how many moles there are of each compound or element. So for in this case, H2 has a coefficient of 3. So down here, you put 3 moles of H2. And then up top are moles of Y, which is again 3. And you do 3 moles of H2. Now, we multiply across the top and across the bottom, and then you divide. So across the top, 2.6 times 3 divided by 3. 2.6 times 3 comes to be 7.8 divided by 3 is 2.6 moles of H2O. And there's your final answer. As you can see, the answer is the same as the starting point, and that would be because we have up here the coefficients are both the same. So 3 divided by 3 comes out to is 1, so basically it's the same answer. So whenever you have a situation like this, you can always just cancel these out, and this is your answer. So that's our answer for this problem. Now, using the same balanced equation, we're going to try a mole to mass problem. So again, we set up our chart, this one having 3 columns. We're going to be given 2.6 moles of H2. Find the grams of Al, which is aluminum. So up top will be our given moles of X, which again comes to be 2.6 moles of H2. Down here is our moles of X, which is 3 because that's our coefficient. So you put 3 moles. Up top is your moles of Y, and in this case our Y is aluminum, so we go up here and our coefficient is 2. So 2 moles up there. Down here is 1 mole, because anything off the periodic table is equal to 1 mole. And up top we go to our periodic table and find the grams of aluminum, which comes to be 27. So we will multiply across the top, and then multiply across the bottom, and then divide. This comes to be 140.4 divided by 3, and when you divide it, it becomes to be 46.8 grams of aluminum. And here's your answer. So now again, using our balanced equation, we're going to try a mass to mole problem. Given 3.89 grams of H2O, we're going to find the moles of aluminum oxide. Okay, so in this column, or in this chart, we again have 3 columns. Up top will be our given grams of X, which is H2O. Down here will be the actual grams of X, which comes to be 18 grams. Up top, 1 mole. Down here is your moles of X. X is H2O. We go up to our balanced equation, 3 moles. And then up top is the moles of aluminum oxide, which is just 1 mole. So 3.89 divided by 18 times 3, which comes to be 3.89 divided by 54, and then that comes to be 0.072. We'll write up here so you can see it. 0.072 moles of aluminum oxide. So there we go, and that is our mass to mole. Now again, using the same balanced equation, let's try our 4th and final stoichiometry problem, a mass to mass. For this one, we're going to be given 0.89 grams of H2O, and we're going to find the grams of H2, hydrogen. So now we're going to make our chart again. This one having 4 columns. Now up top will be our given grams of X, which is 0.89 grams of H2O, which is 18 grams. Up top is 1 mole, because that's what everything off the periodic table is equal to. Down here is our moles of X. X is H2O, 3 moles from our balanced equation, and then our moles of Y, which is H2, which is 3 again. Down here is 1 mole, because again, everything off the periodic table is always equal to 1 mole. So then on top we have our grams of Y, which is 2 grams of H2, and then we're going to multiply and divide. So let's do 0.09 times 3 times 2 divided by 18 times 3, which comes to be 5.34 divided by 54, which then for our final answer, which we'll bring down here, is 0.098 grams of hydrogen. So now, that's how you do all 4 different types of stoichiometry problems. So one more time, let's just go over the different types. There's mole to mole, mole to mass, mass to mole, and mass to mass. For each one, you need to make sure that you follow from here the pattern of the table where you go from here to here, up, diagonal up. And make sure that your units always match. Like in this case, we have grams and grams, moles and moles, moles and moles, and then grams. And then you always multiply it across the top, across the bottom, divide, and there's your final answer. Congratulations, now you know how to do stoichiometry.